Raz. O.
Dwa. Raz, dwa, raz. Tak? Lepiej? O. Raz, dwa, trzy. Możemy zaczynać? Dzień dobry. Oh, I'm supposed to speak in English. Welcome to my talk. Hitchhiker's Guide to CI/CD Pipelines. My name is Jakub Zalas. People call me Kuba. I'm a software architect, developer, trainer, consultant mainly. Let's start by defining what integration means. What does it mean to integrate? Oxford Dictionary. It means to merge, to combine, to mix. Right? Combine one thing with another to make a whole. That's the main definition we'll use today. But the second one is interesting because it applies to continuous integration as well as the first one. Because I feel like continuous integration brings people together when they try to apply the CI principles that apply to CI process. So continuous integration is a process of integrating work frequently. There's no continuous integration without a revision control system. Well, you could try doing it on FTP, but that's quite inefficient, I would say, and error-prone, constantly updating each other's changes, right? Overwriting each other's changes. So version control systems like Git, Mercurial, whatever you use, are critical, central part of CI system. So continuous integration is a process of integrating work frequently. What does it mean? Most of the time we have some kind of a central repository, most of CVS systems are decentralized these days, but we still treat that GitHub account or Bitbucket account as a central store for our code. And we still have one main branch, like a master branch, develop branch, whatever we call it, that we integrate to. Right. So there's some history in that repository, in that master branch. And developers, most of the time, fetch the branch locally or create a new branch locally, do their work, make commit. Hello? Make some commits, and then they merge it back, so integrate it back to the main branch. So it becomes part of the whole thing that other devs can use, right? When there's one developer, there's no issues, because he only needs to integrate with themselves. However, problem starts when Alice makes some commits, and then Bob comes in, and he's a bit cheeky. He refactored half of the subsystem that Alice is using, and merged it back quicker than Alice managed to finish her work. Right, she continues, adds more commits. What happens when she tries to merge back? It doesn't add up. Right, so if you, I hope you all use some kind of a version control system. So you know what to do. You either rebase, so try to base your branch on top of a newer commit rather than the old one you created your branch of. And that will require you to solve any conflicts that might have been created by Bob. Hopefully you are able to talk to Bob and discuss what was changed, and together you'll be able to solve it on your branch. So basically all the commits will be reapplied on top of a new commit, some conflicts will arise, you'll fix them, and at that point, your branch is kind of compatible with the master branch. So you can easily merge it back. All your commits will be merged back to the master branch. Another way of doing kind of the same thing would be merging the master branch to your branch. Again, solving those conflicts, which will make your branch compatible, and you'll be able to, again, but this way history is kind of kept. I mean, chronological history. So that's kind of most of us work this way, right? We create branches, try to merge back. But the key here is how often you do that. Because if I leave that branch hanging for a month, it's going to be rather hard to merge it back. If I leave it for 6 months, it's probably impossible. It's probably more worth it to rewrite the whole thing. I'm not sure if any one of you ever had a branch hanging for 6 months, but it's just impossible. Code progressed since then so far, so much, that it's just impossible. So continuous integration means we integrate work frequently. What does it mean frequently? I would say at least daily. Several times a day. At least daily. And why? Well, if you try to do that, who actually integrates their work daily? Nice, quite a lot. Good to hear, good to see. So frequently, daily. This changes the way developers work. This changes the developers plan their work, approach their work. Because I'm not going to refactor the whole thing and implement the same feature in the same time, and implement the new feature in the same time. Spend a week or two working on that. I'm going to try to think, what can I do today to get my stuff merged? Right? And then Bob might notice, I need to refactor that thing. You know, would be nice to use the decorator pattern there. Let's do that first. I'll get it in, and then both of us can benefit of that change. Right? You start planning your work differently. And as a side effect, after a while of doing this practice, your code is production ready all the time. Because you no longer commit broken code, you don't commit half-baked features, but you try to focus on smaller steps, smaller increments, adding up to the feature you're working towards. Start planning your smaller features as well. Makes that developers are better organized. That's the second aspect of continuous integration I was talking about in the beginning. The developers start talking to each other more because they want to avoid those integration problems on a daily basis. This kind of encourages refactoring. In the opposite scenario, if I had a branch open for 2 weeks, I'll probably break something on purpose to the other person, or I will try to avoid refactoring at all costs. Because I know I'm going to change that code, I'll have issues merging it back in. Right? People will try to not to do that. So they won't refactor. But if you do that daily, it's much easier to make those changes, those small changes. And that refactoring is something we should be doing every day, not have refactoring sprints or whatever. So thanks to that, quality can be maintained over long periods of time, because refactoring is encouraged. Actually, it's probably better to do that refactoring step in a separate pull request, which is easier to review, quicker to review, because you only have one thing to review, the refactoring step. That leads to quality long term. We spend less time chasing bugs and more time implementing features. if you introduce a bug, introduce a problem to the, your build starts failing, it's much easier to fix that if you do it daily or in short, frequent increments. And that's because you still have that in your head. You know what you were doing yesterday or this morning. It's easier to refer, oh yeah, I've done that. That's how you fix it. Well, if it was 2 weeks ago or a month ago, you probably don't remember. I don't know, fix it, right? This gives a lot of visibility into the code base. Problems are spotted sooner, so they can be fixed sooner. You know that chart that shows the sooner you spot the bug, the less costly it is to fix. But continuous integration is not only that merging bit, it's just the beginning. Because once we merged, how do we confirm that this actually works as expected? Right? So we have to build it. We need to run tests to confirm, yeah, that's still okay. You can run inspections and we want, so make sure that code quality doesn't suffer, the test coverage is still okay. It isn't on decline. And then analyze feedback. We will get feedback from that build, so it might be just okay, not okay, but might be more complicated than that. We can see trends, changes over time, things like that. So it's not feasible to actually do that manually. You can try. A month ago, I was working on a prototype of something. That was a prototype, so no tests there. I want to prove to the client that's a good idea to go with. This is the architecture we want to use. So no tests. And it was fine. A few days, the whole thing was working. But then I got feedback. And that required me to refactor the architecture a bit. And that was a pain without tests. I had to test everything manually. After a few days of work, it was already a pain. Normally, I write tests on a daily basis, so those who don't write tests, I don't really know how you work, really don't understand that. So this has to be automated for this process to be efficient, right? Just if you have a build system without tests, it's not really a continuous integration server, it's a compilation server, I don't know. Both version control system and tests are crucial to a good CI system. To add to that, they need to be fast. So they need to mostly be based on unit tests and then some system integration tests. That's the only way to make your tests fast. Then you need that integrate button. It's a metaphor of a button. What I mean is a script, a command that you run when you integrate. That runs all the inspections, all the tests, all the migrations you need to confirm everything works. That has to be no effort task. Just run it every time you merge. Right, so tests are really critical for a CI system. They need to be automated, whatever kind of tests you have, but you should focus on unit tests mostly. With no unit tests, there's no quick builds. There will be some number of component tests, some system tests, some end-to-end tests, some functional tests, but less of them than the actual unit tests. Because end-to-end tests are slower than unit tests, for example, it's good to categorize your tests. Tag them, group them. PHP has this option to group them with annotations. So that you can run your fast tests first. You can also group them in separate test suites, your unit test suite, your functional test suite. Run your unit tests first. If they fail, there's no point of running your functional tests, right? You need quick, fast feedback as soon as build is broken, you want to fix it. So categorizing your tests helps you with that. Tests need to be repeatable. It can be that on one environment they pass, on another environment they don't, or they occasionally fail on your CI server, which happens. If that happens, you need to get into the bottom of the issue as quickly as possible and make sure that doesn't happen. Because what you're after is confidence. You need to be confident your CI system doesn't make mistakes. If tests fail on every first day of a month, it doesn't really give you confidence. Right? That needs to be fixed. That happened to me. Nice way to get into testing and to increase your coverage is to write tests for defects, for bugs. Each time we discover a bug, first thing we do, write a test for it, prove the bug exists, and then fix the bug, not the other way around. That's actually how I got into testing, by writing tests for bugs. And finally, make sure that you get a good feedback when the test fails. The only way to do it is really to do TDD, because when you do TDD, you see that error initially. You write a test, you see it fail. If the message is not descriptive, you can always change it. That's going to help you once your build system fails, right? It's a difference between, oh, there's a failure of this class, okay, I know where to go, versus 500 error on the website. Then you start debugging, right? Be more specific what failed. Then, when your tests pass, you can run inspections to make sure code is on the level of quality you want to accept. Right, various things you can do. You can make sure that code complexity is not exceeding specified limits. Perform design reviews continuously, like from simple coding standard checks to dependencies between your packages, making sure that coupling is not bidirectional, right? Reduce duplicated code. Some tools even can detect bugs, and there's a whole other talk about the tools themselves. And finally, you can access test coverage, right? If you're fairly good with testing, if you're doing DDD, that's probably not going to help you much. But if you're trying to improve your coverage, code coverage is a very good tool to get some insights into what's already covered and what's not. CI, when done well, helps you to support your other dev practices, right? Because suddenly testing is easier, testing is encouraged, it's actually easier to write tests than not. CI will complain otherwise. Refactoring I already mentioned. If we integrate frequently, we want to do that refactoring frequently. That's how it's supposed to be. While opposite scenario, if we spend weeks on a single branch, that refactoring is kind of discouraged. Yeah, so those daily merges are a good way to build that into your workflow. Coding standard compliance, small releases. That's interesting because as soon as if we get into that habit of making those small commits, merging frequently, it suddenly turns out that every commit we merge to master is deployable to production. Because we no longer commit half-baked code, we commit finished or, well, we basically commit finished features. Sometimes, for big features, we might use techniques like feature flags to disable the feature, provide stubs for a service, things like that, just to get that production ready, right? It is still there, it's integrated. It might even be deployed to production, but it's not enabled on production. Kind of detaches deployment from enabling a feature. And really, very important thing, collective code ownership. There's nothing worse than people protecting their single module and not being interested in other modules. Right, CI process encourages that collective ownership. People suddenly start caring about the code base as a whole rather than their specific babies. To make the CI practice effective, it's really important to fix builds as soon as they happen. There's a build failure, we stop everything, fix it. Right? We need that confidence in the build system, otherwise it's not going to work. So managers should be made aware of it. They should understand the important role CI servers play in the dev practice and should complain if that build hasn't been fixed. It's been an hour, why it's still broken? It might be obvious, but not everyone realizes that. I still haven't spoken about CI servers as a server. You can still do that CI practice without actual Jenkins instance or Bamboo, whatever you want to use. But it's important that you make your builds on a dedicated machine, not a developer machine. Like development might have some uncommitted files, some environment-specific configurations. That's where Works on My Machine came out of, right? Works on My Machine because I have some magic config in there. It should be independent machine that we build on. I already mentioned it should be a non-event. It should be easy to build. So either automatically or with a single press of a button on your keyboard. And frequent commits, that's something we all need to learn. It's sometimes hard, but making sure that features are delivered incrementally is crucial here. Once we do that, we can move to continuous feedback. And that's when we install that continuous integration server, pictured Travis CI, which is one of the simplest ones. You configure it with a YAML file and just specify what commands you want to run. But what's important here, that once you have that integration server, you start getting regular feedback. Email, Slack, whatever, on your health of your code base. And it's a rapid feedback. It's there on every commit. You can trace trends, changes, install all kinds of tools that will give you feedback on the quality of your code base and whether it's suitable for production. It gives you a lot of opportunities to learn. To understand what's your project about, right? So doing that really boosts the confidence, especially if you do it from the beginning of the project. You gain so much confidence, and if your manager comes to you and says, can we deploy tomorrow? Yeah, we can deploy today, next hour, whatever. Every commit is deployable. And really decreases the human activity required to manage the whole thing. Because everything is automated, just a click of a button. Once you get that confidence, you can make any commit potentially deployable. So you can package it up, publish it somewhere, whether that's a Docker registry, S3 bucket, or whatever is your way to deploy. Every build will get its version, and every build is potentially deployable. There's lots of ways of doing it, a bit of lower level talk than this one. But in this screenshot, you can see two examples you might do it. One is just packaging it up as a tar archive, putting it on S3, and then you can take it from there. Another way might be just create a Docker image and tag it, push it to your registry. So you can take that image, even fetch it locally, run it, play with it, deploy it to production. having that, there's really small step to the continuous deployment. Once you have that image, you can automatically deploy your pull request builds to dev environment or master builds to UAT environment. Some even deploy it to production directly. I never worked on such a project, but people do that. More often, it's that you deploy to some kind of a user acceptance testing environment, and then when everything is fine there, you promote it to pre-production and then production with a click of a button, obviously. But again, it should be a non-event. Command you run. Not sure what deployment systems you use. These are 3 that I used in past. Really old days, Capistrano, that basically syncs files to the server. You can use Helm charts to communicate with Kubernetes cluster and deploy it from a Docker image. And most recently, I used the Fargate with ECS from Amazon, which is quite nice. It reads just your Docker compose definition, and you can push your image to your ECS instance. So how to introduce all of it? Got distracted, sorry. It's best when you introduce a CI server on day one. One of the first commits you make, you introduce a build system. Not a fully featured build system, a simple one. Even if there's no code yet, you have index.html file with a placeholder, this is a new service, hello, or a health check. You make sure it's built or even deployed to your cluster or whatever wherever you deploy it to. I'm really shy. What was I? Oh, yeah. So start small. The whole thing will grow as you progress, adding features, adding more code. And because of that, you'll get a lot of confidence in the build system because you tested it from the day one. It's going to grow. You're going to add more features, add more inspections. And actually, to add an inspection or a new feature on the CI server, I wouldn't do it on the day you think about it. I would first, well, discuss it with the team, but I would identify the problem. We have problem with coupling with this. Someone keeps injecting repositories to entities. This shouldn't happen. Well, yeah, that's a problem. How do you prevent that? Well, there's this tool, deptrack. We could use it to track dependencies between modules. How about we try that? OK, let's try that. You create a config, start using it. That's the first step. You start using the whole thing you just configured. Tell other devs, yeah, give it a go. Over time, you tweak the config, make it more suitable for yourself. And once you feel it's time, then you put it on the CI server. Now we can automate it and run inspections on every step. Right? Just to end all of this, I'd like to show you how easy it is to configure a CI server. This is a Jenkins CI server, which is highly customizable. There's lots of plugins for it, but no means I endorse it or anything like that. I use whatever is suitable for the project. Disadvantage of this is you have to host it, although there's a hosted solution as well, but there's also fully dedicated hosted solutions. You can choose from like Travis or Silky CI or Bitbucket has one. So this is just an example. Whatever CI server you'll use, you'll need to configure it to do the similar things. So in case of Jenkins, I like to install a couple of plugins like Blue Ocean and Warnings NG. Blue Ocean is just a nice interface for your pipelines that is greatly simplified and nicely visualizes your pipeline. In this screen, you can see that it's installed from a command line, but you can just click it through on the interface and install those plugins you want. It only requires one thing to configure, which is the repository. Right? It might be your Git, your GitHub, your Bitbucket, whatever you use. Give it a path, create a pipeline. It's going to complain at first, there's no configuration for it, but you store the configuration in the repository. So it will find all the branches that have a config file, which is called a Jenkins file, and register them in the CI config. And example Jenkins file, you configure your pipeline, CI pipeline, so everything is, there's two ways to configure Jenkins. One way is scripted pipeline. This is a declarative pipeline, which is a bit cleaner, easier to understand, but as powerful as the scripted one. One thing you have to do, which is irrelevant at the moment, you need to configure the agent. The whole thing is going to be run on. We don't care, so just NA. But you might say, please use this Docker file, or please use this Docker image, and it will run all the commands that follow in that Docker image, which is quite handy. Right, but the main thing we want to configure here is stages. Stages are your steps in the build process. So it's going to be build, test, inspect, package, deploy, whatever you define as your pipeline. Yep. And then everything inside is just steps. These are dummy steps here. You can start with that just to have your pipeline run. But as a build, you could just use Composer install, run some migrations, generate code you need. Basically, make your application workable, deployable in a single step. Then you can run your tests to see if this application is actually working. So you're probably going to run PHP unit, bhat, PHP spec, whatever you want in here. And advantage of using Jenkins is it has lots of plugins and lots of standards you can follow. So PHP unit as well follows the JUnit output standard, so integrates with most of CI servers. You can take it from there and make Jenkins publish those reports, both JUnit or HTML, just a bit of config. This will be invoked post the pipeline is run. Sorry, not the pipeline, the stage, test stage, right? So once all the steps are run, it will try to publish the reports. The stage might fail because tests might fail, but the reports will still be published. You still want to see the failures. Right, and this is how it looks like in Blue Ocean plugin. You get the coverage report, you can track it, have it easily accessible, use it in your code reviews. Inspections, similar thing. You should get the idea by now. In this case, we just run PHP CS fixer as a command and record issues. This is warnings and G plugin that can record most of inspection standards. Again, you'll see this in Jenkins as a nice report with a history of track changes and so on. Right? Then we can package it. Last project I used, we packaged it as Docker images, which basically means you have to build the Docker image, tag it, and push it to your registry. Right? So all the builds will have its own unique tag that's in the Docker registry, so you can take it and deploy it to an environment. Right? Project version is just whatever way you version your system. I use the git commit hash here, but that's really not that important. I would rather use a tag or something like that. Right. And Jenkins will build it, push it. And finally deploy. Really, deployment is the whole topic for a new talk. In this case, I just use Helm charts to deploy. the build image only if it's a master branch. Right? I didn't want developer builds to be placed on the UAT, just the master branch whenever we integrate our work. And that's just an example of pipeline. Obviously, you introduce more tools that's going to add up to the whole execution type. You want it to be fast, so you can run steps in parallel. Jenkins pipeline system is very, very feature-rich, so you can do that. That's just a very simple example on the introduction. I talk like this. Thank you very much. That's all I have for you today. Are there any questions? At the end, I'll get this one first.
Okay, so at first you advise to merge daily, but usually after pull request there's a code review that have to be accepted by at least 2 person. Yeah, and other things that have to be done. So how to schedule it, or do you have any tips for it?
Yes, but if you do it daily, your changes are much smaller. So those changes are very, very quick to review, right? And maybe 2 people is an overhead. I never seen it working when people complain about the review process, it's always at least 2 people they need. That's my experience. I'm not saying that I'm advising less or anything, but that's the common pattern there. So maybe 2 people to approve is too many. I think 1 is sufficient. And then since your pull requests are smaller, more focused, it's just a refactoring or just adding a feature, it will be easier to review, so developers will more likely to review it quicker, I think. Well, that's my experience at least. Not sure if it helps you. Well, it works for me, yes. Of course, initially you need to bug people and ask them, please review, please review. But eventually they get into habit. Some people try to introduce daily hours for reviews, like first thing after the stand-up, let's review all the pull requests pending. That might get them into the habit of reviewing. Yeah. There's a question in the back.
Okay, maybe a short question. What are benefits of Fargate over EC2 instance? Fargate versus EC2.
It's because I'm lazy, I prefer Fargate. Because with EC2, you need to set up the image, deploy it, set up all the networking, all the policies, all the rules. With Fargate, it's kind of, most of it is created for you. And it's just one command. It's like a Docker compose app. ECS compose app, starts the service, down, it kills everything. Just easy. For most of use cases, works.
Is there a possibility to run the CI test locally? Or yes, all of them? All of them?
Not all of them. Travis is only hosted solution. Jenkins, that's what I shown. I run it locally. Many of them have dedicated local versions, but yeah, some are fully hosted. So that's up to you to choose what you prefer, right? Some people don't like to be vendor locked in, and it's just, in some organizations, just impossible to use a hosted solution. They have to host their own. So.
My question is more like, I've seen there was CS fixer, yes, and probably I would like to run the CS fixer locally first before I will run it on the CI, yes, because the feedback will be.
Yes, I didn't make it clear. Every developer who should have those tools, or at least most of those tools, set up locally with one command. So a makefile, composer, you can use composer hooks for that. Whatever you use that to set up the basic set of checks. Maybe not all of them will need to be there, because if you have a complicated end-to-end test suite, it's going to take 2 hours to run. You don't want to run that locally. But all of the other things, yeah. Make test, make build, whatever.
Thank you. And one more question is, do you have some kind of test which run after putting after deployment to production?
I usually use health checks for it. So there's an endpoint on the service that responds with its state, I'm healthy or not, and then you can verify whatever you want in there, like database connection is there, whatever you need. I usually use that approach. And most of like Kubernetes have built-in, or the Fargate system with Docker Compose, it uses Docker Compose, so it also supports health checks. So if you define health check in your Docker Compose, it's gonna automatically use it and ping it to see if your service is still alive and report, yeah, it's healthy, no, it's not healthy, let's restart it. Make sense?
Can you compare, for example, GitLab CI solution to the Jenkins solution?
So I might be getting old, but I don't care. They're just solutions. I mean, whatever works for you. I'm a consultant, so I work with so many of them. Initially, I was resisting it, and it's like, you need to use this tool, you need to use PHP spec, you need to use Travis CI, but it's not sustainable. So I learned to just accept what, according to them, is acceptable solution, because all of them do the same. Just a list of steps that if any of them fails, your build failed. Maybe some reporting, that's it. You configure a Jenkins file or a YAML file, translate one to another.
How you handle post-deployment action? For example, cache clean, migrations, or something like that. It's CD server responsibility, or you do it other way?
So it's the command that you use to deploy, in my view. So in the times of Capistrano, when I was deploying with Capistrano, that was Capistrano scripts that were doing it. In case of Docker, I don't have to do it at all these days. So, but either way, it's during the deployment when you do that. Because if that fails, you need to roll back to the previous version. Does it make sense? You're not convinced. Let's talk after the talk more, because I think we need to finish. Thank you for coming, and if you have more questions, just ask me directly. I'll be here on the barbecue.